Here's the complete dataset. 5 test flights, each shown in a different color. The orange points aligned along the upper boundary correspond to the maximum AOA turn started at 525 knots with full aft stick deflection held manually at the maximum achievable angle of attack. Next, I begin filtering points by SEP, starting from the sustained turn region with an altitude tolerance of 200 meters. Tightening the SEP tolerance step by step, 2, 1, and 0.5 meters per second, reduces the number of valid points but also decreases their scatter along the line. Once filtered, I plot the trend line. The next line corresponds to SEP equals 25 meters per second, forming the full EM diagram. The plot also shows load factor lines at 3, 6, and 9G. As mentioned earlier, there's a subtlety often overlooked regarding load factor readings. The cockpit G-meter shows acceleration along the aircraft's vertical body axis, while the kinematic turn rate uses acceleration perpendicular to the velocity vector. At angles of attack around 24 to 25 degrees, the difference can reach about 10%. Aircraft manuals from different eras and manufacturers may use either convention. The easiest way to tell which one is used is to compare published load factors and turn rates at low speeds, where AOA is high. If they follow the standard kinematic relation, the data are in the velocity frame. If not, if it's the body axis projection. In this case, I'm using the velocity frame kinematic G-load. This diagram can also be used to compare available load factors in non-steady turns. For example, the German Air Force Flight Manual lists the minimum speed for the maximum allowable 9G as 370 knots. In my test, it came out at 385 knots. Very close. Let's also look at the characteristic speeds, turn radii, and rates of turn. The maximum instantaneous turn rate reached 27.5 degrees per second at about 385 knots. The maximum sustained turn rate was around 21 degrees per second at 500 knots and 9G, though it's slightly more efficient to reduce speed a bit, which lowers the radius and, more importantly, the load factor, extending time before G-lock. The minimum turn radius theoretically occurs below 200 knots, but in practice, as the test points show, optimal performance is achieved around 220 to 250 knots, with a turn rate of roughly 18 degrees per second. Still quite respectable. Hopefully this video will be useful to you. Ciao.